Welcome everyone to The Explainer. Today we're popping the hood on a digital fighter's brain to see how it actually thinks, and honestly, more importantly, how it actually feels. Picture this. You are down to just a tiny sliver of health in a fighting game. You try to bait the computer with a fake out, you throw a quick jab, and instantly, perfectly, without a millisecond of hesitation, the computer counters your move and knocks you out. It doesn't even feel like you got outplayed, right? It feels like the machine just read your mind. Well, if you've ever thought the computer opponent in a video game felt a little too omniscient or just a little too artificial, you are absolutely not alone. So we're looking at a fascinating case study today, a fast-paced 2D arena fighter called Stick Brawl, and we're going to uncover how it uses a brilliant programming technique called fuzzy logic to completely change the game and power genuinely human-like AI. Okay, let's dive into this. Have you ever wondered why so many video game enemies feel completely robotic? You know the exact feeling I'm talking about. You play against the computer, and after a few rounds, the illusion just totally breaks. You realize it's basically just reading your controller inputs and reacting with mathematically perfect, entirely predictable responses. It feels cheap, it feels lifeless, and honestly, it completely takes the fun out of the challenge. So how do we break the curse of the omniscient machine? How do we build an enemy that actually hesitates, makes judgment calls, or gets overwhelmed just like a real player would? Well, to understand how we fix this, we first have to look at the deeply flawed foundation of how traditional game AI is programmed. It all comes down to this core comparison right here. On the one side, traditional AI relies on hard thresholds. It operates in absolute black and white. On the other side, fuzzy logic AI operates on degrees of truth. It allows the computer to understand gray areas, making decisions that are fluid and context-aware, much like a real human would when they're sweating it out in the heat of a battle. And this is why this matters so much for game developers. Because the ultimate goal in game design isn't to create mathematically perfect opponents. No, the goal is to create the illusion of humanity. That is the core thesis of our explainer today, how fuzzy logic ditches the rigid math to power genuinely human-like AI. So here is our roadmap for today. We'll start with the robotic AI problem, then enter fuzzy logic, look at reading the game state, explore the fuzzy rule base, and finally, how the AI takes crisp action. Section 1. The robotic AI problem and those hard-coded behaviors. In older or simpler games, programmers rely heavily on strict, hard-coded if-else scripts. For example, the underlying code might literally say if HP is exactly less than 30%, then run away. Now, the fundamental flaw here is that absolute unyielding boundary. Imagine you're fighting this enemy. At 31% health, the enemy is a ruthless gladiator, aggressively punching you in the face and pushing its advantage. But the literal millisecond their health drops to 29%, their behavior snaps entirely. They forget all about the offensive and they immediately run for the hills. Real people simply don't think like that. We don't have an internal switch that just flips from fight to flight over a 1% difference in vitality. We weigh our options dynamically based on multiple, constantly shifting factors. Which brings us to Section 2. Enter fuzzy logic and these fascinating degrees of truth. To fix this rigid behavior, the Stick Brawl engine uses what is called a Mamdani fuzzy inference system. I know, that sounds incredibly intimidating, but don't let the academic name scare you. Grounding it simply, this framework just allows the AI to exist in gray areas. Think about holding a cup of coffee. Is it hot or is it cold? In traditional computing, it has to be exactly one or the other. But to a human, it might be perfectly warm, somewhere right in the middle. Instead of viewing the game world purely in ones and zeros, true or false, this system allows the AI to understand that a combat situation might be partially true and partially false at the exact same time. Under the hood, this system uses what's known as a multiple input, single output pipeline, or MISO for short. Basically, every single fraction of a second, the game runs through these exact 4 steps to calculate its next move. First, it reads the raw inputs from the arena. Second, it fuzzifies them, taking that raw math and translating it into human-like feelings and degrees of truth. Third, it evaluates its strategic rules based on those feelings. And finally, it defuzzifies the result, turning those abstract feelings back into a concrete physical attack or block on your screen. Moving right along to step 1 in that pipeline. Section 3, reading the game state through 4 crisp inputs. Every single tick of the game, the engine grabs 4 crisp, raw numbers: the exact pixel distance to the player, the AI's current health ratio, its mana ratio, and the threat level from incoming projectiles, like fireballs. But raw numbers aren't fuzzy yet, right? So it maps these numbers into linguistic categories using triangular and trapezoidal mathematical functions. Just think of overlapping triangles on a graph, where a single number hits the slopes of multiple categories at the exact same time. Through this math, a numerical distance becomes categorized as close, medium, or far. Health becomes low, medium, or high, and so on. And this brilliantly illustrates the whole concept. Let's say you're at exactly 150 pixels away. Traditional AI would just call that medium range and be done with it. It would lock into its medium range behavior. But the fuzzy engine, it calculates that 150 pixels is actually 33% close, 85% medium, and 0% far. The distance actually belongs to multiple categories simultaneously. The AI understands that while you are mostly at a medium distance, you're also creeping just a little bit close for comfort. Now let's see what it does with that information in Section 4, the fuzzy rule base and expert combat strategy. The game encodes expert combat strategy into 10 specific if-then rules. Here are just a few examples straight from the source. If distance is close and HP is high, then melee rush. Or if HP is low and threat is moderate, then full defend. Now imagine you're aggressively rushing the AI in the arena. The distance is categorized heavily as close, but the AI's health is teetering on low. To combine these competing conditions, the engine uses what's called the min method. It takes the lowest mathematical value of those two fuzzified inputs to calculate a firing strength for each specific rule. Because of this, multiple rules can, and totally will, fire at once. One part of its digital brain is screaming to counterattack because you're close, while another part is desperately urging it to block because it's dying. It weighs these options dynamically, just like a human player deciding in a split second whether to fight or flee. And here is a truly surprising detail about how this is actually implemented in Stick Brawl. Changing the game's difficulty doesn't actually make the logic dumber. The AI still uses the exact same sophisticated fuzzy math on easy mode as it does on hard mode. The only thing that changes is how often these rules run. On easy, it runs the logic every 14 frames, simulating a slower, less experienced human's reaction delay. On hard, it reacts almost instantly, recalculating its fuzzing logic every 4 frames. It's just a fantastic, elegant way to scale difficulty without breaking the AI's core intelligence. Finally, we hit Section 5, taking crisp action and executing the actual move. So once all 10 rules have been evaluated, we have a bunch of competing desires. One rule wants to attack, another wants to defend, and another wants to throw a fireball. We have to convert this mess back into a single physical action on the screen. This final step is called defuzzification. Stick Brawl uses a method called the center of gravity. Honestly, just think of this as a giant visual funnel where all those competing desires are poured in. The engine aggregates all those fired rules, looks at their firing strengths, and calculates a beautifully weighted average. So the crazy part is, all of this complex, multi-layered fuzzy math collapses down into one thing, a single, crisp output number on a scale from 0 to 100. And that single number dictates the AI's final action. The scale is divided into 3 distinct percentage zones. If the center of gravity calculation lands in the bottom tier, exactly between 0 and 33%, it triggers a defensive action, like retreating or throwing up a shield. If the number lands in the middle 33%, specifically from 34 to 66, it triggers ranged harassment, prompting the AI to hurl fireballs or use reach attacks to safely maintain its distance. And finally, if the math pushes the number into that top 34% block, anywhere from 67 all the way to 100, the AI gets highly aggressive and relentlessly rushes in for a close quarters melee combo. Now, there is a brilliant fallback mechanism at play here too. You might wonder, what happens if the AI is just standing there, you are standing there, and absolutely none of the rules fire? Does the game crash? Actually, scratch that. Does the AI just freeze up like a broken robot? Nope. No way. The engine safely defaults the center of gravity to exactly 50. This keeps the AI actively engaged in neutral harassment, constantly probing your defenses from a safe distance, dancing back and forth until a new rule gets triggered. As the game's documentation perfectly summarizes, the real magic here, and they really hit the nail on the head with this, is that the AI behavior is smooth and graduated. Because of this fuzzy math, the AI doesn't snap abruptly between states. At 60% health, it doesn't just instantly switch from attack mode to defense mode. Instead, it gradually shifts its mathematical weight between attacking and defending based on all 4 inputs simultaneously. It's fluid. It's organic. This fluid, organic shifting is exactly how fuzzy logic bridges the gap to human-like AI.
Let's unpack its true market value and strategic potential today. We're covering the core AI problem, target markets, revenue paths, a quick SWOT analysis, and the growth roadmap.
You know how traditional game AI feels totally robotic? Well, fuzzy logic changes that completely.
Enter the Mamdani system. It actually processes gray areas, giving fighters way more unpredictable, human-like behavior.
And this isn't just for gamers. Academics, indie devs, and competitors represent a massive, untapped market.
The real business value here? It's basically a live, transparent teaching tool for fuzzy reasoning.
So how do we actually monetize this? We've got 3 highly scalable models lined up.
First up, a freemium model. We sell cool cosmetics but keep the core AI completely fair. Next is B2B. Bootcamps and universities can literally pay to license this transparent AI tooling.
Finally, an open core approach. We give out a free engine to build community, driving paid instructor editions.
Looking at our SWOT analysis, our biggest strength is absolutely that visually rich, built-in transparency. The catch? We've got a MISO limitation right now, collapsing complex combat decisions into one output.
But hey, that opens doors. We can expand those outputs and package it into university modules. Our main threat, though? The rapid rise of neural networks, potentially outperforming our handcrafted fuzzy systems.
So, how do we adapt and grow? Check out our 4-phase strategic roadmap.
Phases 1 and 2 are all about scaling outputs and building over 20 complex fuzzy rules.
Phase 3 is the real game changer. It's a neuro-fuzzy hybrid using reinforcement learning to auto-tune parameters.
Finally, Phase 4 deploys this directly into university AI labs as a slick, browser-hosted educational tool.
Okay, now we start with the demo. This is our project, which is the name is Street Brawl. It has some music here when we turn on, and then it will show the music. Okay, so let's start the game. So here we have the start game versus AI, and then we have the training mode, practice combos and spell on a standing dummy. Which next is the survival mode, where we face endless wave of enemies to see how long we can survive. Next is the versus mode, where player versus player, where we can challenge a friend locally using the same keyboard. And next is our settings, and which let's see what we have in the settings. We have 3 options that we can change, which is the AI difficulty. The next one is the chaos mode. We can turn on and off the chaos mode, and also the round timer. In our game, we have 3 different characters with 3 different stats. The first one is the Aqil Mage. Next is Iron Brawler. Next is Shadow Ninja. We only have 3 characters, and the dice is for randomizer, which is randomized character that the system will choose. So next is the map. We have 3 maps, which is the first one is Neon Arena, second one is Storm Peak, and the last one is Volcanic Temple. We also have option to random to choose randomized map. So here is our logic dashboard demo. The changes here will be automatically changed based on the AI movement, our movement, and our HP, and so on. If the distance, if our distance is close to the AI, or the AI health is low, or our health is low, based on that, it will changes the settings. For the quick scenarios, like R1, if the enemy is close and have if AI close and have high HP, it will do melee rush to attack the opponent. And also R5, it will changes these kind of things. This is the charts and also the system that the system act on. So it's also build fire rules based on the situations of AI and the player movement. the analysis details. Here will be shown all the past history and the gameplay that we had, all the damage, all the matches, all the win rate, all the combo, and even AI damage, and also their skills, combo, and so on. Next is the report details. In report details, we include introduction, the objective of the game, and the gameplay system. We also have system rules and conditions for Fuzzy Logic AI, where we have 4 Chris inputs, and each input is falsified into linguistic membership degrees. And we also have 10 rules that will be shown later. Here is the input variables and membership function, distance, health, and mana and threat. Here is the fuzzy rule. We have 10 rules, which rule 1 until rule 4 is the melee rules, which is the aggressive pursuit, which is attacking method. In rule 5 and until rule 7 is heroes rules, and rule 8 and rule 10 is the defense rules. Other than that, we also have the inference and diversification. And next is the AI difficulty and reaction speed. Based on that, also based on the difficulty, and it will react on the reaction speed of the AI. We also have knowledge acquisition, market analysis, who are our target users, what is the value and the benefit of the system, and also the SWOT analysis, what is strength, weakness, opportunity, and threat the game have, and also the growth roadmap. And also we have conclusion of the game, and here is the reference that we took to create this game. And lastly is our members. So that's all from us. So if you try this game, I hope you have fun and you enjoy playing this game, and I hope we can get some feedback if you are interested in the game. So thank you.